Well, thanks for coming. So this is a presentation about why we test and getting our feet wet with how we test. So first, why test? Well, let me bring to mind some historical examples. The Hindenburg, the Titanic, Justice League. What do all these things have in common? No tests. So why do we test? Well, we test because we love software that is reliable, because you love software that is secure, because you love software that's fast, because you love software that is easy to understand, because you love software that is easy to modify, because you love software, because you love your colleagues, because you love your users, and because you love yourself. So one thing I want to impart to everybody is that tests don't just help you write better code. Tests make you write better code. If your code is untestable, that's a really good sign, or hard to test even, that's a really good sign that your code could be improved. So the other thing I want to impart is when you hear a requirement, you think test. In fact, that's actually not quite right. When you hear a requirement, when you think tests, plural, because the quality of your tests equals the quality of your code. So here's an example. It's a classic tweet about a QA engineer. Walks in the bar, tests all these conditions, and then a user comes and tests something that, or does something that wasn't tested, and the bar bursts into flames. That's an example of not having, let's say, full coverage. So the other thing you should understand is that better tests mean more confident refactoring. If the tests are reliable, then if you change something, that it'll catch something if it breaks. So this can be you. Look at that confidence. So as an example, let's go on a bug hunt. Can everybody see my IDE here? In fact, let me check out earlier version, sorry. So this is the famous FizzBuzz program. This is just simply you print the numbers 1 to 100 if you're not familiar. And every multiple of 3, you print fizz. Every multiple of 5, you print buzz. Every multiple of 3 and 5, you print FizzBuzz. Otherwise, you print out the number. So we can run this. And here's our output. Any moment. There we go. So that, first glance, that looks correct, right? But I can tell you that your interviewer is not impressed because there is a bug here. If you know it, don't say it. It's part of the exercise. But this is it's a classic mistake that people make with FizzBuzz. And so, how could we actually find out if this is working correctly? Well, we can eyeball it, but that's not terribly reliable. Right now, this code is just untestable, right? Like, it's just one component that just prints to the console. So let's try this one. Nope. Yes. Okay, good. All right. Here is a improved version. So now we're still calling FizzBuzz, but actually we are returning a string. And this way we actually have it's a bit more modular. We have a component that returns, or a method that returns a value that we can now test. That isn't just straight to the user. So we also included here a naive test. This is sort of a smoke test or an end-to-end test. This just checks. We have here the expected values. This is our FizzBuzz program. And here we just check that our program or our method outputs the expected output. And now we try to run this and it fails. Okay, well, yeah, eyeballing, that looks, pretty close. You may have seen the mistake, but I need to close that Zoom thing. There we go. Okay, so this is good. We at least know that it's wrong, but this test is pretty naive. It's a bit too high level. We don't really know why it's wrong or what specifically is wrong. So we can try another example. Here we go. So now we actually built a whole nother, there it is, component. And now this actually just takes in a single number and returns the expected value. And so now we can actually start testing, does 3 return fizz, and does 5 return buzz, and does 1 return 1? And in fact, this is what we can do here in our tests, right? So here's our smoke test, and here's our unit tests. So let's run our tests here. Okay, well, these 3 all passed, but our smoke test still wrong. So we know that if we pass in 1, we get 1, 3, we get fizz, 5, we get buzz. So, well, what's wrong? Well, let's remember our requirements, right? There was one more requirement that's not covered in our test case, which is multiples of 3 and 5 should be fizz buzz. So let's try that. Okay, so there's our requirements. And now the missing test. So given 15 returns fizz buzz. All right, and let's go check out our program. Let's see what happens. All right, that test is failing because we don't meet that requirement. So what can we do about this? Well, we can I'll just show you guys the refactor. I don't really want to spend a bunch of time watching me live code and then, miss something and go back and be like, why doesn't this run? Anyway, so, okay. So now we have a little more sophisticated program with dad indentation. So this is, we've actually changed it a little bit. So now we append the string, and if the string is length is equal to 0, then we just do the number. So now let's see if our test passes. Here's all our test cases. Look at that. It passes because we've covered all of these cases here. Now let's try looking at another example. So, if I have to stash the changes, that's funny. Okay. So here's our tests. Now let's look at another example of a program that passes our tests, but actually really sucks. So this guy, so this actually catches all of our test cases. And so this is what I meant by the quality of your tests is equal, determines the quality of your code, because our tests are still, not that great. They certainly could be better, and they are not catching what is, I call in my commit message, hot garbage. So how do we fix that? Well, it's actually unclear what is wrong. This looks, first glance, everything looks kind of correct. So we could write another test that say, just copy this, and given 20 returns buzz, like maybe that's breaking for some reason. Or, you see, we're just having a lot of these repetitive tests, a lot of copy pasting. So this is the part I was excited to show you guys is parameterized tests. So instead of just writing like, this over and over, we have this handy annotation in IntelliJ, or sorry, in JUnit, not IntelliJ. They don't get the credit for this, which is parameterized tests. So let's take a look at what that would look like. All right, so I'll walk you guys through what's happening here. So here we have just re-implemented all of our tests with a parameterized test. So we built this method here that returns iterable arguments. And I imported just this static list method from arrays. If you're curious what that is. And here we have our original inputs. We had a test for 1, 3, 5, and 15, and these are the expected outputs. And here is that annotation at work. So let's call it parameterized test. And then you add an annotation for the method source. You don't have to do this. You could actually, it's smart enough, I believe, that if we wrote parameters test, I think this would work, but let's find out. No, it would not. I'll try one more thing, because we're live and recording, so no one wants to see that. Anyway, better to just be explicit. So we call it parameters. Now we're telling it that you want to run this test with each list of arguments here. Here we have one list, which just covers all our cases. So this test should actually run all of our tests. We'll see that these tests still pass, but our smoke test is still failing. So, well, let's try writing more arguments. Does anybody have any questions so far before I just start coding away?
When did they add parameterized test to JUnit? Because remember, that was the selling point of using Spock on Groovy before.
That's a great question. And with very little research, I'm going to say JUnit 5.
Fair enough.
But yeah, that's a good question. I actually don't know when they added that. I think it is JUnit 5, but
yeah, no, I'm glad that it's there now because yeah,
oh, it's
much nicer.
Yeah,
so much nicer.
It's so much nicer, and like your tests become a lot easier to maintain. Like we have one test that's accomplishing what we were doing in like 5 tests earlier.
Yep, and like let's make this extensible and add another 20 digits to it. Great, here you go.
It's like super easy to just, yeah, exactly, like add more arguments. Like, well, I want to test this case. I want to test that. I want to order -1 beers.
Yeah.
So let's see, maybe we can try 3, 6, 9, and 99. And oops, that's silly. So as list. Then as list, we just expect fizz over and over again. All right, let's see what happens.
Comma and space.
Comma and space is what's happening. Thank you. Boop. This is why you don't do it live. Oh, interesting. We expected fizz, but we got 6. All right, so without even looking at our hot garbage, good sense of what went wrong. Okay, so let's change this to num modulo 3 equal to 0. Try that. And our test pass. Great. So all our tests are passing, but we are not done because there's cases we have not covered. List. Let's try 5, 10, 20, and 100. Okay. Oh gosh, what am I doing? We want buzz over and over. And nope, what did I do wrong? Oh God, abort, abort. You know what? Okay. Oh boy, 5, 10, 20, 100. Buzz, 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 and buzz. Okay, thank you all for bearing with me. Let's run our test again. Look at that, another failure. So we could fix that. And you sort of see where this goes, right? And then we still have a bug. 0. run it. All right. Let's try one more time with 15, 30, 45. That's probably enough. FizzBuzz. 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 Okay, so run it again. And look at it, we add a test, we find a bug, right? So this is everything we're doing here is just checking a requirement. You know, multiples of 3. Okay, well, we tested one multiple of 3 before. That wasn't enough. Now we're testing more and we found a bug. Same thing with the 5s, same thing with the 15s. So we can, you know, I'm just going to check out the next commit. So we can save ourselves a little bit of time here. I have a stash. Okay. All right. So as our FizzBuzzer. Oh, that's not right. Well, whatever. So let's see here. We have more tests. These should be passing, but I guess I messed up my commit history. So whatever. Let's oh no, that does work. Aha. Aha. That should work. There we go. All right, look at that. And our smoke test passed. So here's all of our tests, each of which helped us actually get to this finish line. And now we have, you know, quite a bit more confidence that it works, especially now that our smoke test is passing. And so now that we know that it works, we can actually like refactor this code because it's, you know, it's not awesome this way, right? It's got a lot of, you know, statements, don't love it. And so let's just refactor that. All right. So does anyone doubt that this solution works if our tests are passing? Does anyone think we have introduced a bug here? I would say chances are low, not impossible, but we've got pretty good coverage here. Let's see what happens. Look at that. We were able to refactor it with pretty high confidence because we had this test. And this is like, you know, this solution looks a fair bit different from the previous one where our tests are passing. And so that's sort of, again, just to reinforce, like the quality of a test is equal to the quality of your code. And the tests sort of force you to write better code. That, you know, our original example was just not testable. And our original test was just not that good. The smoke test could tell us something was wrong, but not what or where. And now by having what amounts to, gosh, I don't know, 13 tests, not including the smoke test, you know, we have a much better sense of that this code works, and that, you know, if we make changes in the future, we can be confident we didn't break anything. So that's, you know, pretty much my soapbox speech. Anyone have any questions?
JUnit has some really powerful features built into it. Have we explored using some of the performance type behaviors with JUnit?
Ooh, I have not actually. I know that like Pat is a performance testing expert, so he's done some pretty amazing stuff with the IceCube code. But no, I personally have not explored that. That's actually something I would love to look into and maybe do a presentation on that.
I've seen, like, in reading documentation, I have seen that it existed, but also I haven't seen how it's done. So yeah, that would be an interesting one.
That'd be very cool to have, actually.
Because it's exactly this sort of case. This then you can test your refactoring to see, did your performance increase or decrease?
Yeah, I think that's great. Because that's also, you know, code can't just be correct. It needs to actually, you know, be performant, right? And there's I'm gonna have to really paraphrase here, but there's an expression that, like, you know, sufficient latency is indistinguishable from downtime, right? If FizzBuzz, this program takes 2 minutes to execute, people are gonna be like, it's not working. And we would, if we somehow did something to our implementation that caused this dramatic slowdown, it'd be good if our tests caught that, right? And in fact, that's a fairly, not that extreme example, that's fairly common as you add new features and you refactor things, it's very likely, unless you're trying to improve performance, it's very likely that you degrade performance because you're just asking it to do more or do something differently. And so it's good to have some, standards in place somewhere that catches that and just lets you know, even if you're like, I'm okay with the performance costs, it's good to know that, you're making that trade-off. Yeah, great question. Anybody else have questions? Anyone else is excited to get out and test things as I am? Excellent. Okay, well, I guess that's it then. Thanks, everyone. I will be doing another one of these, probably a few more. I've got more topics I want to cover. And yeah, hopefully, I'm going to try to keep them as short and sweet like this, so that our millennial attention spans can handle it. Cool. All right. Thanks, guys.